So 6b electrostatic force. So number one, what is the magnitude of the electric force between the two spheres? Right, and so we know that, well, Q1, our knowns are, well, the charge of one is 4 times 10 to the negative 6 coulombs. And we know charge 2 is negative 3 times 10 to the negative 6 coulombs. So we know that the distance between the charges is 2 meters. What was the magnitude of electrical force? Right? We want to find out, we want to find out what Fe is. And we know that on your reference table, your formula for electrostatic force is this formula right here. And well, what does K what is K equal to? Well, K is the electrostatic constant, which is also on the first page of your reference table. And it's going to be 8.99 times 10 to the 9 Newton meter squared over Coulomb squared. So now we're gonna plug this all in. K is 9. We're gonna round this to 9 times 10 to the 9, okay? 9 times 10 to the 9 times Q1, 4 times 10 to the negative 6, right? And Q2 is 3, negative 3 times 10 to the negative 6 well, I don't really need coulombs there, so let's just ignore it. And R squared is 2 squared. Now, there's an easy way to do this without a calculator. Of course, you can always use a calculator, but to do this without a calculator, which is what I'm going to do, you can separate all these numbers, right? You can do 9 times 4 times negative 3. Right? I'm pulling out all the individual numbers, divided by 4, because 2 squared is 4. And I'm going to multiply this by 10 to the 9, 10 to the negative 6, 10 to the negative 6. And so what I'm going to do right here is 9 times 4 is 36 times negative 3. 36 times negative 3 is going to give you 108. So negative 108 divided by 4. And the rule for multiplying exponents is that the exponents are going, if you have a multiplication between exponents, what you're going to do is you're going to add them, right? So 9 plus negative 6 plus negative 6, that's going to give you negative 108 divided by 4, 7. Negative 27 times 10, well, 9 plus negative 6 gives you 3, plus negative 3 gives you negative 3 here. So you're going to get that number, and we simplify it. We're going to simplify this number. 2.7 times 10 to the negative 2 newtons. All right, if we plug this into your calculator, you're going to get the same exact number. And again, I did all this without a calculator. All right, if you want to use a calculator, you can do it using a calculator, but make sure to use the correct order of operations. Don't plug in everything at once. And if you want to look at that again, just look at it, just replay. So number 2, what the number of excess elementary charges on sphere A is what? So the charge on sphere A is 4 times 10 to the negative 6 coulombs. Right, and so there are two ways to solve for this. Well, how many excess elementary charges are on the sphere? Well, one thing you can do is you can divide, well, if we know that one elementary charge has a charge of 1.6 times 10 to the negative 19 coulombs, what we can do is you can divide this number by this number over here. All right, so because we're dividing this total charge by the charge of one electron, and you're going to get the number of electrons here. So again, we can separate this. 4 divided by 1.6 is going to give you 2.5. 10 to the negative 6 divided by 10 to the negative 19. What you're doing here is you're minusing, right? So what when you divide exponents, negative 6 divide exponents, what's going to happen is that you're going to do 10 to the negative 6 minus negative 19. All right, and that gives you what? That gives you 10 to the 13. 10 to the 13. So 2.5 times 10 to the 13 elementary charges. And that's choice C. So the answer is C. Well, the other way of doing this is, well, if we know that 1 coulomb of charge is 6.25 times 10 to the 18 elementary charges, we know that, well, that's a proportion, right? Well, so if we have a charge of on sphere A of 4 times 10 to the negative 6, right? We know that's in 1 coulomb of charge. Well, then we can just do, hold on, this is equal to, so 1 coulomb, there's 6.25 times 10 to the 18. And we're gonna just do a proportion here. So you're gonna cross multiply this right here, and then that's what you get. You get a number. So 4 times that, you get 25. 10 to the negative 6 times 10 to the 18 gives you 10 to the 12. And you simplify this, you get 2.5 times 10 to the 13. And that is also still the answer. All right. So now we do number 3. What is the magnitude of the electrostatic force exerted on an electron by another electron when they are zero point 0.1 meters apart? Now, well, we know the charge of my first electron is negative 1.6 times 10 to the negative 19 coulombs. Guess what? It's another electron, and so it's going to have the same exact charge. All right, same exact charge, and so we know that the distance is 0.1 meters apart. And we know that the electrostatic constant, again, I'm rounding it, is on the first page of your reference table, is that. And so you want to figure out, well, what is the electrostatic force, right? And so that's K Q1, Q2 over R squared. And we'll do the same exact thing I did above. I'm going to separate all my numbers, and let me write this out first. So that's electrostatic constant, negative 1.6 times 10 to the negative 19. That's charge 1. Charge 2 is negative 1.6 times 10 to the negative 19. Right, and we're going to divide it by r squared. So we're going to square that. And I'm going to separate my numbers again. I'm going to move all my exponents to the other side and move all my normal numbers to the left-hand side. And so I get 9 times negative 1.6 times negative 1.6. 0.1 squared is going to give you 0.01, right? Times 10 to the 9 times 10 to the negative 19 times 10 to the negative 19. Right, I'm going to move all the way over here, okay? So 9 times 1.6 times 1.6. Let's solve that, and I can't even do that in my head. I'm sure there's a logical way of doing that. And so I'm going to get 23.04 divided by 0.01 times 10. So what's going to happen here is going to have these exponents adding together. So 9 plus negative 19 plus negative 19. All right, and so now we're going to get here 23.04 divided by 0.01. And you get 2,304. And the exponents here, well, 10 to the 9 plus negative 19 is going to give you negative 10. Negative 10 plus negative 19 is going to give you 10 to the negative 29. Okay, so how do we resolve this? Well, we have to simplify this. What's going to happen? Let me move this to the other side. This is going to become 2.304. Moving decimal places 3 spaces over. And I'm going to get, what's this? 10 to the negative 26. Okay, so 20 newtons. So the answer choice is C. That's the answer. Number 4. Electrostatic force exists between two point charges, and when they give us the charges, plus 3.2 times 10 to the negative 19 coulombs, and charge 2 is also still plus 3.2 times 10 to the negative 19 coulombs. Okay, so you separate a distance of 0.03 meters, and that as the distance between the 2 point charges is decreased. So as your radius decreases, right, as your distance decreases, what happens to your electrostatic force? Well, guess what? Let's look at this formula right here. This is a conceptual question. All right. So K Q1 Q2 over R squared. What we're gonna do, right here. All right. So as the distance increases, well, if you think about it, let's think about it this way, right? If you don't know how to solve this, I was thinking too hard. Think about it. If you have 2 point charges, right, they're both positive, and you increase the distance between them, and now it's double, right? It's double now. That's R. Well, is a attraction going to increase or decrease? I mean, first off, it's repulsing because it's 2 point charges, right? Two positive point charges, so they're repelling each other. Two positives repel. And so if you increase the distance between them, what's going to happen is that the repulsion is going to decrease as well. If you ever thought of two magnets, right? When you get two north poles of magnet together, and you get them really close together, what's gonna happen is that they're gonna repel. You feel that really strong resistance. But as you pull these magnets away, you don't really feel that repulsion anymore. And so as your radius increases, what's gonna happen is that your electrostatic force is gonna decrease, and your repulsion, because it's two positive point charges, it's gonna repel. So the repulsion decreases. So now let's look at number 5. And so number 5 says if a charge if the charge on each of two small metal spheres are double, the distance in the sphere remains fixed. The magnitude of electrostatic force between the two spheres will be 1. So again, we'll look at this formula right here. All right. And if you double the charge of these point charges, well, what's going to happen is K2Q1 times 2Q2, right? Because you're doubling your charge. Well, then you get 4KQ1 Q2 over R squared. What's this number compared to your original number? Give you a hint. It's 4 times, right? You see this 4 right here. So D, 4 times is great. All right, number 6. Two electrons are separated by a distance of point 3 times 10 to the negative 6 meters. So we know that the first charge, right? We know the first charge is negative 1.6 times 10 to the negative 19 coulombs. So we know the charge of our second object, our second electron rather, is the same exact charge because it's the charge of one electron. It's on your reference table. And the distance is 3 times 10 to the negative 6 meters. All right. Now, again, we want to find out our electrostatic force, and we know K is 9 times 10 to the 9 Newton Newton meter squared over Coulomb squared, and that doesn't really matter that much. All right. And so we know the formula for electrostatic force is this formula right here. It's on your reference table. All right. Now, what we're gonna do, right? What we're gonna do is, and we're just gonna plug all our numbers in. K is 9 times 10 to the 9, right? Q1, negative 1.6 times 10 to the negative 19. The second charge is the same exact charge over 3 times 10 to the negative 6 squared. All right, again, we're going to do the same exact thing. We're going to separate these numbers individually. So 9 times negative 1.6, negative 1.6 over 3 squared, because again, all I'm doing is squaring the 3 here, times 10 to the 9, 10 to the negative 19, 10 to the negative 19, and 10 to the negative 6 times 10 to the negative 6, because that's what all that square is doing. This square right here means you're multiplying this number by itself twice. And that's what that is. So this is going to give you 23.04 divided by 9. Right? So times 10, 9, 10, 9 plus, okay, I'll write it out for you. So plus negative 19 plus negative 19, because that's what exponents are. If you multiply them, you're adding the exponents, down here as well. So negative 6 plus negative 6. And let's move it all the way up here. So 23.04 divided by 9 is going to give you 2.56. 2.56 times 10 to the 9 plus negative 19 is negative 10 plus negative 19 is negative 29. 10 negative 6 plus negative 6 gives you 10 to negative 12. And now, so since we're dividing exponents, we have to subtract them. So negative 29 minus negative 12, right? Because we're dividing, so we have to subtract the exponents. If we're dividing exponents, we have to subtract them. And now we get 2.56 times 10 to the negative 27 newtons. And that answer is, well, it's your A or B now, right? So we have two electrons. Are they going towards each other or they're away from each other? Well, they're repelling, right? Because they're the same charge, so they go away from each other. So the answer is A.